Apologies, it was ridiculously slow queue. Next year, when we do this, we're going to have a queue management session, just to help develop interdisciplinary solutions to lunch. But really this morning what we had were just some really super interesting and fascinating talks at that global and local perspective. And this afternoon we're really going to look more at some of those smaller systems and how there are barriers and challenges within those. So the two sessions this afternoon are really around the circular economy, right? So how we think about material flows, and then around how we build collaborations and how we work with external organizations to be able to deliver change. But I have the privilege of chairing the circular economy session, so that's where my research fits. And we've got three speakers who are going to talk to you today about their work. So Lois Pennington is going to start us off. She's doing her PhD. She's in the final year.
Final day.
This is how important you all are. Rather than prepping for a PhD viva, she's here talking to you. Based in the Tyndall Centre for Climate Change, and she looks at LCA and environmental impact assessments for waste management in airlines. So she's going to be talking to you about that. We'll then second have Nicholas Enrique Labra Cataldo, who is also a PhD researcher in the Tyndall Centre for Climate Change. They just have clearly too many and not enough PhD students at the same time. Again, very much circular economy strategies, but with a particular focus on e-waste. And then Zixian Su, who is a PhD student in the Henry Royce Institute, and he works on how to circularize, or at least upcycle or downcycle things into cements, and so we'll be talking about low-carbon cements. So first up, Lois. We are going to try and use mics so that the people at the back can hear. That's how it works.
Okay, that's working. Great. Cool, thank you so much, Mike. Moving on to my slide. Yeah, my name is Lois Pennington. I am a final year PhD researcher at the Tyndall Centre for Climate Change Research at the University of Manchester. And today I'm going to be talking to you all a bit about some of the work I've done over the last 3 years. So just to give some context for what I'll be talking about today, in 2022 there were over 3.7 billion journeys taken by international flights. And on all of these flights, jet fuel was burned, which generates greenhouse gases. It's been estimated that the aviation fuel burn causes up to 4% of global warming emissions. And with things such as electric flights and hydrogen-powered planes still several decades away from commercial scale use, there are some short-term options that we have to minimise the impact of these flights. Things like operational efficiencies, reducing the overall number of flights, and the uptake of low-carbon jet fuel, otherwise known as sustainable aviation fuel. But beyond the impact of these flights, beyond the impact of the fuel, the aviation industry has another environmental impact to deal with, that of cabin waste. And it's cabin waste that I'm going to be talking about today. So why is this an issue? Well, depending on the length of flight and the class of flight, between 200 grams and 2.4 kilograms of cabin waste, so things like leftover food and packaging, is generated per passenger. And it's been estimated that up to 95% of this waste is actually recyclable or compostable. Almost 50% of it is organic waste, that leftover food that people aren't eating on the planes, as well as recyclable packaging, plastic, paper and cardboard, other amenities provided to passengers. And despite this, in many regions around the world, including the UK, all of this waste must be sent to landfill or incineration. And the reason for that is the potential presence of animal products, so things such as meat and dairy, which can transmit animal diseases like foot and mouth disease across borders, is a potential biohazard. So anything that has contact with this food waste, or might potentially have contact with it, is considered a biohazard. and has to be sent to landfill or incineration. This is in places like the UK, the EU, the US, and a lot of South American countries. And it's this that I'm going to be talking about today. So there's 3 research questions that I'm aiming to answer over this presentation. The first is how much international catering waste is there, because there aren't any reported numbers at a national or even regional level. The second is what is the existing environmental impact of handling all of this catering waste. And finally, what are our opportunities to reduce it? So focusing in on this first question, as I said, there aren't any reported numbers at a national or regional level. Some airports do report the amount of catering waste they dispose of. However, due to the number of organisations involved in the disposal of catering waste, you have airlines, you have airports, you have catering companies and waste disposal companies. Typically, it doesn't provide a full picture. So to overcome that, I mapped all of the incoming flights to the UK in 2022. Here is an example of all of the incoming flights, commercial flights to Manchester Airport in that year. And depending on the number of passengers that travelled on each route and the length of the flight, I could use a waste generation factor per passenger and sum them to find the total amount of waste coming to each airport. And I did this for each commercial airport in the UK that receives international flights, and then you can sum them together. So, with 91 million passengers coming to the UK in 2022, that resulted in around 89,000 tonnes of international catering waste. And just to say as well, I'm using 2022 numbers as the most recent data, but of course the COVID pandemic was still impacting the aviation industry. So these numbers are only around 75% of the passenger numbers pre-pandemic, and if the aviation industry continues to bounce back, as it is expected to, these numbers are of course going to increase. So, for a bit of comparison, the city of Aberdeen in Scotland generated the same amount of household waste in the same year, around 90,000 tonnes. However, of course, in Aberdeen, you can segregate your recycling, you can segregate your compostable waste, and this is being treated in better ways than landfill or incineration, whereas all of this international catering waste coming to the UK is being sent either to landfill or incineration. So it's a city's amount of waste that is not being treated properly. And just to look as well a bit more at the geographic spread, so most of this waste, over 50% of it, was coming into the London area that you can see here. And in fact, if you just draw a 50-kilometre circle around the Greater London area, which incorporates the airports of Heathrow, Gatwick, Stansted and Luton, 73% of all of the UK's international catering waste is incoming to the most densely populated part of the UK, meaning that not only is this an environmental problem, but a management, logistics and disposal problem as well. So, moving on to the second question, what is the existing environmental impact of this catering waste? So in order to find this, I used life cycle assessment, which has been defined as the systematic analysis of the potential environmental impact of products or services during their entire life cycle. And what this allowed me to do was create comparative scenarios for waste disposal to compare, for example, landfill and incineration, as well as other methods of handling. In scenarios where energy could be generated, such as electricity and heat, that was considered as a credit, as it would displace the electricity that's currently generated partially from fossil fuels. And where materials could be recycled, that would displace mining any more virgin material. For example, if you generate a kilogram of aluminium through recycling, you no longer need to extract the kilogram of aluminium from raw materials. Life cycle assessment allows you to compare a lot of different impact factors, but for this presentation, I'll just be talking about global warming potential because of time. And the results that I'm going to present here are specific to the goal and scope of the study, so it's not considered so much a carbon footprint, but more of a way to compare between different handling methods, just for reference when the graphs come up onto the screen. So, I mentioned that we don't know how much catering waste, there aren't any reported numbers on how much catering waste there is, and what there also isn't reported is how it's being handled. So we know it can go to landfill or to incineration, but we don't know how much is going where. So I modelled the two extremes, what if everything is going to landfill and what if anything is going to incineration. So looking at everything going to landfill, all of the biodegradable waste as it degrades in landfill generates methane. Part of this methane can be captured and burnt for small amounts of electricity and heat, but it is a small amount per kilogram of waste. And for the incineration, I modelled all of the combustible waste going to incineration, while the inert waste, like glass and aluminium, was being sent to landfill, things that aren't appropriate for incineration. And that also generates electricity and heat, or a larger volume per kilogram of waste compared to landfill. So, the results are on the graph here of those two scenarios. So you can see the environmental burdens as everything kind of above the zero line, and the environmental benefits from avoided products are below. So starting with landfill, you can see that the vast majority of the contribution to this scenario was from the landfill itself, and that's due mainly to methane, as things like the organic waste, almost 50% of this waste is organic, is breaking down in landfill and generating methane, and you get a very small amount of avoided burdens from generating electricity and heat. Incineration also generates carbon dioxide as you burn the waste, particularly the fossil waste, such as plastics. However, you have a larger amount of heat and electricity that's generated from the waste, and so the net result is around, here in this black diamond, is around a quarter of the size of sending it to landfill. So we have arranged for what the existing climate impact is, and now I'm going to look at ways in which we could reduce it. And I looked at two potential ways to reduce the impact. The first was using an alternative thermochemical conversion method. So incineration is one thermochemical conversion method. I looked at what if we could use a different type. And the second is ways in which we could enable recycling as well. So starting with that alternative thermochemical treatment, the reason I looked at using a different thermochemical treatment is because the current use of incineration is because of the potential risk of transmission of animal diseases. So if you use a different thermochemical conversion method, in theory, the risk of transmission of animal diseases shouldn't change. So I looked at gasification, which is a high temperature process above 700 degrees done in limited oxygen. And when you gasify a feedstock, you end up with something called syngas, which is a mixture of carbon monoxide, hydrogen, and carbon dioxide mainly, with some other contaminants. And you can do a few things with syngas. You can directly combust it, so you can generate electricity and heat from it. Or you can do something potentially more interesting and use something called the Fischer-Tropsch process, which kind of takes the carbon monoxide and hydrogen and smashes them together. And you end up with alkanes, liquid fuels, liquid transport fuels at different lengths. And I looked, in this case, at the modelling of kerosene, making biokerosene, because kerosene is what you can mix it with jet fuel and use it in flights as a biofuel. So it's that rubbish to runway kind of cycle. So that gasification method, again, it's only appropriate for combustible waste, and you have your avoided products of electricity, heat, and also now your biokerosene. And the results of that show that, again, you see a reduction in global warming impact, global warming potential, compared to the two existingly permitted disposal methods. So you have your emissions from the gasification and Fischer-Tropsch process here, but you also have your avoided emissions due to the electricity, heat, and now also the kerosene. So you can see that there's a potential to reduce the global warming impact of the waste through gasification instead of the current two allowed methods. Moving on to the ways in which we can enable recycling, I looked at three potential scenarios for this. The first was the segregation of beverage containers on board the flights. So beverage containers such as PET bottles, glass bottles, and aluminium cans. Under existing UK law, you can segregate these on the flight, and as long as they are not having any contact with animal products, typically they wouldn't contain animal products, as long as they're put in separate bins and kept separately, you can then recycle them when they arrive in the UK. I couldn't find any evidence of this actually being done. Some airlines are doing the segregation, but there's no evidence that once they then arrive at the airports, it's being handled separately, so kind of kept in separate bags, but then thrown into the same bin anyway. Because there's so many organisations involved in the waste disposal process that everybody needs to be on board to kind of enable this. So in this scenario, I modelled the recycling of the glass, the aluminium cans, and the PET bottles. In the next recycling scenario, I considered that all of the waste from the EU would be considered low risk. So everything that is originating from flights in the EU could be treated domestically, so we can recycle the recyclable waste. We can send the food waste to an anaerobic digester, which generates biogas, and also something called digester, which can displace traditional inorganic fertilizers. And then the rest is incinerated or sent to landfill as appropriate. And the reason that I considered this is because under current UK law, as an individual, you can freely bring animal products from the EU to the UK. So you can bring meat, you can bring dairy, with the exception of pork products, because there's an outbreak of African swine fever in Italy. But everything else you can bring, and as long as you don't feed that to an animal once it's here, you can dispose of it as you wish. So that law is directly at odds with the requirement to treat waste that is coming from the EU as a biohazard. There's two laws that say different things. And when we used to be a member of the EU, we were allowed to do this. Again, I didn't find any evidence that any of the airports were actually segregating waste like this, but you were allowed to. And the final scenario, I kind of expanded upon that a little. So the EU is free of most of the animal diseases that are a significant risk. And in this one, I looked at all of the countries in the world and their animal health status. And anything that was considered high animal health, so free of things like foot and mouth disease, African swine fever, I considered to be safe. So this is especially important for places like the US and Canada. The US is the single largest contributor to the international catering waste volumes in the UK, and so by enabling US waste to be considered as low risk, this could potentially also have a significant impact. So here are the overall results, again with the benefits and burdens. So you can see here that this scenario, the segregation of the beverage containers, you have your emissions again from the incineration of the residual waste. You have some benefits from the electricity and heat, but really interestingly, this dark green colour at the bottom is avoided burdens from the aluminium process. And that's because recycling aluminium uses around 10% of the energy consumption as it does to generate virgin aluminium. And aluminium is in theory recyclable infinitely, so by keeping that in the loop, you're avoiding having to generate that new virgin aluminium. If we look now at the different sort of scenarios where I considered waste to be low risk, segregating waste from the EU also performs reasonably well. You have your incineration burden, but also some benefits from the avoided products. And then considering the waste from places that are high animal health, like the US and the EU and other countries, also performed better because, of course, you're considering more waste to be low risk. But overall, the biggest reduction was seen by just segregating the beverage containers on board planes. So just to draw some final conclusions, I've modelled that the UK handled almost 90,000 tonnes of waste in 2022, predicted to increase if the aviation industry continues to grow at the current speed. Current handling methods of international catering waste are resulting in significant greenhouse gas emissions, and we have the potential to reduce it. One such way is using a different thermochemical conversion method, so gasification, which could reduce the impact compared to current handling methods. In addition, changing the policy to allow waste that originates from the EU and to be considered as low risk could create a benefit compared to current handling. And interestingly, especially if the US was to be considered as low risk, that could have a significant impact on handling. But I think the most interesting finding is that the segregation on board of the beverage containers actually provided the best global warming improvement compared to current scenarios. And this is in theory something that could be done this week if airlines just began to segregate on board and the airports and everyone involved in handling on the ground also had the correct infrastructure to handle all of that. And this wouldn't require any policy change, only operational changes. And that's it.
Questions for Lois? Yep.
Hi, my name's Matt from the University of Birmingham. I think that was a really nice presentation. I'm really insightful into that sector of the aviation industry. I know you said because of time you're only looking at global warming potential, but considering other environmental impact factors, does that change the outcome or the recommendations at all?
So if you consider the other global warming, so the other impact factors, considering waste from high animal health countries tended to perform the best. And the reason for that is the recycling of aluminium has quite high ecotoxicity impacts because of the copper cathodes that they use in the aluminium process. So it performed very poorly in those sectors, which impacted like the overall performance. And so the high animal health segregation performed best if you kind of look at all of the impact factors weighted equally.
Great, thank you.
Can I take chair's privilege to just follow up on that aluminium point?
Mm-hmm.
So in your numbers, you're saying, okay, we've got this big benefit because I'm avoiding virgin aluminium mining. but the can that is on the plane is already made out of recycled aluminum.
Yeah.
So how, is that cheating a little bit in terms of who's paying for what? Because if the can that's on the plane is then already made of recycled materials, why are you claiming the whole benefit? And is
Yeah.
everybody claiming the same can 100 times to justify overconsumption of pop?
Yeah, yeah, it was all Coke's fault. No, so the way that I performed the LCA was kind of considering all the waste that is already there and not like allocating emissions to like people who had like generated the waste, just kind of this is what we have and like what happens in the different ways that we dispose of it. But I mean, it is an ongoing conversation in life cycle in general, like can you really consider waste to be burden-free, like who is really responsible for that? So yeah, I mean, I know it's an ongoing conversation.
Anything else? Yeah, up at the back. Yeah, that's you.
Quick one. Have you explored the option of airlines going away from animal products as a kind of waste stream, so kind of going vegan or anything like that?
Yeah, so I mean, in explored, I mean in my thesis I said that they should consider it because there's a couple of things. One is most of the animal diseases that are at risk of transmission are transmitted in things like beef, pork, and lamb meat, which are higher anyway, have higher sort of associated greenhouse gas emissions compared to like vegetarian or chicken and fish options. So even moving from like heavy meats to kind of more chicken and fish could reduce the risk and also reduce the associated impact. But yeah, if you turned the entire menu vegan, then this issue would actually just go away entirely, provided people didn't like sneak a ham sandwich onto the plane or something. But they might be doing that already, we don't know. Yeah.
We couldn't even get a vegan outside here. So. Please join me in thanking Lois.